Today, we will talk about the ridge regression, which is one of the most popular statistical methods when you make prediction. Let's say we want to predict y variable, and we have two predictors, x1 and x2. So we are going to use these two variables, x1 and x2, to predict the values of y, which we do not know. But before diving into ridge regression, I want to mention that all variables are demeaned. So here, the demean means that we subtract all variables by its own average. The reason that we do demeaning is that we can exclude the intercept in the regression formula. And that makes a lot of things easier when you make a prediction. First, I just wrote down about the regression formula and how to estimate beta in normal regression. So this is what we learned before. And I'm going to compare the normal regression and the ridge regression to explain why we need ridge regression. So the regression formula is the same as the normal regression, but the way to estimate the beta, it will be different. So let me write down how to estimate the beta coefficient. So we are gonna find the beta 1 and beta 2, which can minimize something, and that something is gonna be have some part which is same as before. So we want to minimize the part of we want to minimize the formula, and that formula actually includes the summation of the square residual. But we have additional term. So the additional term has lambda, which I call parameter, and also beta 1 square plus beta 2 square. So let's just interpret what it means. So we want to minimize this formula, but we have beta 1 square and beta 2 square. So if we have larger values for beta 1 and beta 2, that means actually we are going to have larger value for all this formula. So we don't want that. This means actually we shy away from larger values for beta 1 and beta 2. We want to have smaller values for beta 1 and beta 2. So this is why we call this term as penalty term. So if beta has larger values for this beta 1 and beta 2, then actually we shy away from that beta. We want to have smaller values for beta 1 and beta 2. The reason that we have this penalty term is coming out from the mean square error. So let's think about mean square error of beta. Just look at this difference. So this is beta hat, which is what we got, and this is true value of beta. So if you take the difference, then this is gonna be prediction error. We take square and then get the expectation value of this square. So what does it mean? So it means that this is a prediction error. So if we want to minimize the prediction error, that means actually we want to minimize this mean square error. And you can see that this formula can be decomposed into two parts. The first part is going to be the expected value of beta hat minus beta square plus variance of beta hat. So we already saw that this is bias of beta hat. And in normal regression, this is 0, right? Because normal regression generates unbiased estimator. But you can show that in ridge regression, we have biased estimator. So this is non-zero in ridge regression, even though this is going to be 0 in normal regression, which means this is going to be higher. So this is actually against minimizing mean square error. So then why do we need ridge regression? The reason is because we can decrease the variance of beta hat. So you can show that the variance of beta hat in ridge regression is actually smaller than the variance in the normal regression. So this term will go down if we use ridge regression instead of normal regression. So now you can see why we use a ridge regression. Because because they offset each other, so sometimes we can decrease this mean square error, or we can decrease this prediction error when we use ridge regression. So this is why we often use ridge regression when we make prediction.